So you've got the SQL basics down and you're feeling pretty good about it, right? Well, it's time to level up. Today, we are diving deep into the advanced stuff, the concepts that really power high-speed analytics, create bulletproof security, and drive the modern apps we use every day. Let's jump in.
I mean, that's the real goal, isn't it? To go from just fetching data to truly commanding it, making it work for you in really powerful and efficient ways. If that sounds good to you, then you are definitely in the right place.
All right, here's our game plan for today. First up, we're going to tackle analytics and reporting, how to get those crucial insights and get them fast. Then we'll move on to the super important topic of keeping your data safe and sound, and we'll wrap up by looking at how SQL is evolving to meet the demands of today's apps and data formats. Okay, our first stop is all about speed and clarity. Look, it's not just about getting answers from your data. It's about getting the right answers in a format that makes sense without having to wait around forever for your query to finish.
So first things first, you've got to understand that not all queries are created equal. On one side, you have your transactional queries, or OLTP. Think of these as the quick, day-to-day operations. Inserting a new customer, updating an order, they keep the lights on. On the other side, you've got your heavy hitters, analytical queries, or OLAP. These are the big, complex questions you ask to understand business trends. They're built for completely different things.
Now, a huge part of getting speed is picking the right tool for the job, and in this case, I mean the right index. Your standard B-tree index is perfect for columns where the data is really unique, what we call high cardinality, like a user ID. But for columns that only have a few possible values, low cardinality data, like gender or a simple yes-no flag, a bitmap index is an absolute beast. It makes complex lookups on that data incredibly fast. Choosing the right one here is a total game changer for performance.
Okay, let's talk about a classic reporting headache. You've been there, right? You run a query, and you get this long, endless, vertical list of data. It's all there, it's accurate, but it's a total pain to read and compare. So what's the fix?
And the magic solution to that headache? It's the pivot operator. Its entire purpose in life is to literally rotate your data, taking the unique values from one of your rows and turning them into their own individual columns. It's a reporting superstar.
So this is what I'm talking about. This is that raw data. See how you have to scan up and down the list just to compare sales for widget A versus widget B? It's just not intuitive at all.
And boom, look at the difference. This is the aftershot. With Pivot, the months are now columns. You can instantly see everything side by side. It's clean, it's concise. I mean, it's a proper report now.
All right, let's shift gears. Because look, getting fast insights is great, but it means absolutely nothing if your data isn't secure, consistent, and recoverable. In this day and age, this part is completely non-negotiable. And our first line of defense is always encryption. It's basically the art of scrambling sensitive data into unreadable gibberish so that if anyone unauthorized gets their hands on it, it's totally useless to them.
But here's the thing. You have to protect your data in two different states. Encryption at rest protects the data while it's just sitting on the server's hard drive. But you also need encryption in transit to secure that same data while it's zipping across the network from the server to a user. You need both to be truly secure.
You know, security isn't just about building walls to keep people out, it's also about having a plan for when things go wrong. And that means backups. A solid strategy usually involves three types. You start with a full backup, the whole shebang. Then, to save time, you do differential backups, which just grab the data that's changed since the last full one. And for super precise recovery, like down to the minute before disaster struck, you use transaction log backups.
Okay, but that brings up a really tough modern problem. What happens when your data isn't in one neat little box? What if it's distributed across multiple servers, maybe even in different parts of the world? How on earth do you keep it all consistent?
Well, you've got a few key strategies. If you need an update to be absolutely all or nothing, you use distributed transactions, often with something called a two-phase commit. It's like all the databases have to vote yes before any of them are allowed to save the change. Then there's replication, which is all about keeping multiple copies of data in sync. And sometimes, being available is more critical than being perfectly consistent every second. For those cases, you can embrace eventual consistency, which lets the system catch up and sync data over time.
In our final section, we're going to see how SQL isn't just some old dusty tool. No way. It is constantly adapting and evolving to stay critical for modern software, new data types, and all the new challenges that come with them.
You know, great databases don't just happen by accident. They are designed. And that design starts with a blueprint. the Entity Relationship Model, or ER model. Before you write a single line of code to create a table, you map out your entities, like customers and products, and define how they relate to each other. This planning stage is absolutely crucial.
So how do modern apps actually talk to a SQL database? Well, a lot of the time, it's through something called an ORM, which stands for Object Relational Mapper. The best way to think about it is as a translator. It's a bridge between the world of programming code and the world of database tables.
And here's the real magic of it. An ORM lets a developer work with the database as if it were just another part of their code. They can use familiar objects in Python or Java, and the ORM is in the background, doing all the grunt work of translating that into the correct SQL. It is a massive productivity booster.
Now, for dealing with really complex or messy text, SQL has an incredible power tool called regular expressions, or regex for short. When a simple like statement just won't cut it, regex lets you define these incredibly specific patterns to do things like validate an email address format or pull a tiny piece of text out of a huge string.
And speaking of modern, this is huge. SQL isn't just for neat structured tables anymore. Today's SQL databases can natively store, manage, and even query JSON data right inside a column. This means you get the amazing flexibility of a format like JSON combined with the rock-solid power and reliability of a relational database. It's truly the best of both worlds.
Whew! Okay, we have covered a ton of ground. So let's take a second and boil all of this down into a practical toolkit you can use to really start leveling up your own SQL skills.
All right, here's your advanced SQL toolkit in a nutshell. To analyze data, use Pivot for clear reports and make sure you choose the right index, B-tree or bitmap, for maximum speed. To secure your data, use encryption everywhere, both at rest and in transit, and have a multi-layered backup plan. To model your data, always start with a good ER design and use an ORM to connect your code. And finally, to adapt to new challenges, get comfortable using tools like regex and the built-in JSON function.
And that brings us to the final question. We've seen all these incredible tools for speed, security, and flexibility. But as data just keeps getting bigger and more complex, the real question is, which of these advanced tools is going to be the most critical for you to master first? It's something to think about. Thanks for joining me.